Okay, so I was introducing the whole concept of the dwarves and the hi-ho turning into hi-vo, and one of my kids was smart enough to figure out I meant horizontal on the inside, vertical on the outside. That's awesome. All right, and then figure out some good words to the dwarf song, the hi-ho song that go with quadratics. Okay, so moving on. If I, wait a minute, wrong spot. I'm going to hit blank sheet. If I'm doing a synthetic typically looks like this. 5, 7, 2, 8. And if I had all of these, you know how we're multiplying and adding? Can you tell just right off the bat that this is going to grow to be insanely big by the end? And that it won't work? See what I'm saying? You can just think about that and say, if I drop this down, and then I multiply, and then I add, it's just going to keep growing. Right? So you need a few negatives in there to keep this thing from exploding at the end. All right, so I want to give you one that that might or might not work. Let's say, figure out if x equals 2 is a root for x squared plus 8x plus 4. Use synthetic. It'll be real quick, and you'll be able to say, yes, it is a root, or no, it isn't. And then tell me the answer. The answer is not just a bunch of ones and zeros and stuff. All right, so you check 2, and you go 1, 8, 4. Draw the line. Drop it down. Can you see already by looking and seeing they're all positive that this probably isn't going to work? Yeah. All right, so that's good. That's a good sign that you're catching on to that little thing. And it's got to be a really big number. And at the end, I'd like to start the tradition of if it doesn't work, you can just put a big empty set in there. That's like 0 means it works. Empty set means it doesn't work. Oh, did I screw something up? Okay, sorry. 8 plus 2 is 10. 10 times 2 is 20. Once I knew it didn't work, I was kind of sloppy. All right, and then that just means does not work. All right, so let's try another one. Change that to a 5 in the middle. Now, check that quick. And the nice part is positive. Okay. So, did you prove? Is it just because they're all positives? Oh, okay. All right. So, check this. See if that works. Don't try to have too many little tricks. Just use synthetic and prove it or not. Or prove it doesn't work. Use synthetic quick. Just take you a second. Why don't you go 4, 1, 5, 4. Drop it. 5 plus 4, 9. 9 times 4 is 36. Okay, doesn't work. See? That's proof. All right. Now, am I saying that this won't factor? No. I'm saying that 4 is not the factor. That's an important point to get. See, I think some of you are seeing this and going, that factors, Mr. Server, and you're right, it does factor. But it doesn't factor with a 4. What does it factor with? Well, that's what I'm trying to teach you today. I'm trying to teach you today is what's called the rational root theorem, and it tells you what would possibly work. What number would work here? Now, this isn't easy enough that I can just do it in my head quick and say, oh, okay, it factors to x and plus and what? 4 and 1. So then why wasn't 4 working? Well, what would have worked? Negative 4 would have worked. Because, remember, we're talking about the number that would go in here and make it equal 0. That's called the root. This is called a factor. All right. So, bottom line is, how do I tell when it's not so nice? How do I tell what could possibly work in this kind of a problem? Like 5x to the 6th plus 3x squared plus 10x minus 12. How do I figure out what possibly could work? It's not super simple. You have an idea? There is something called synthetic multiplication, but that's not what we're going to do. Okay, what we're going to do is figure out what could possibly work using what's called the rational root theorem. All right, I'm going to start with the easy one. You need to crawl before you walk. It's actually true with babies. They don't actually, it's kind of like mothers when they have a new baby, get a little bit worried because they've heard that if the baby waits and waits and doesn't crawl and doesn't crawl and doesn't crawl for a long time, that's actually okay until if they skip over crawling completely and go directly to walking, that actually has been proven to not be good for the baby, as in the baby might have learning difficulties because a part of their brain doesn't get engaged at the right time, like when they're young. There's little windows in your brain when you learn certain things. Did you know that there's a little window in your brain that's kind of open until like age 10 or something like that, that's really good at processing language, and then it shuts down? Does that mean you can't learn anything after age 10? No, but it's harder. It's way harder. Okay, because that certain part of your brain's like open and ready and can handle language processing. Because when do you learn to talk? Well, up to like when you're young, up to like age 10. Why does that part of your brain like shut down? I don't know, but when little kids get exposed to languages, they can learn 2 or 3 languages pretty easy. That's why that whole thing at the elementary schools is kind of powerful, is they're teaching them Spanish or Chinese during that window of time when their brain's really good at learning and picking up languages. So anyway, and so then they'll know a couple different languages. All right, so this we need to do on a simple one like this one first. Would you agree there's a 1 in the front of that? That's called the lead coefficient. That and this together are the things that tell us what the roots could be. The 5 does not tell us anything in this particular case about what the roots could be. And here's a little nifty way of remembering it. F con over F co. Just write it down. You don't know what it means yet, but I'll explain it in a second. F con over F co. This is a way of finding the possible roots. It's called the rational root theorem, RRT if you want to abbreviate it. I'd put a star by this in my notes because you have to know it. And if you take the factors of the constant over the factors of the coefficient, that's how you get your answer. F con over F co. All right, so what are the factors of the constant? Well, the constant is the 4. What are the factors of 4? How can you make a 4? 1 times 4 and 2 times 2, and I don't need to write the 2 again. There's my list of factors of the constant, 1 and 4 and 2. Over F co, factors of the coefficient. And we're only talking about the lead coefficient here, otherwise it'd be really complicated. The lead coefficient is 1, and a lot of times it is just a 1, and that makes it simple. All right, then, do you get, though, that you could make a 1 with -1 times -1? So you actually have to include positive and negatives on all of these. So I'm fine with, instead of writing the positive and negative time like 10 times, you can write the positive and negative sign just in front of the whole thing. Plus and minus that whole thing. All right, so now, it doesn't look like numbers yet that I could test. But what divide, this right here, this big fraction bar, means divide. So 1 divided by 1 will give me one of my answers. 1. 4 divided by the 1 gives me another answer, 4. And 2 divided by the 1 gives me another answer, 2. Is it always just going to be those 3 numbers? No, because sometimes the lead coefficient isn't a 1. Sometimes this is like a 2. And if it is, then you divide everything by 2 and by 1, because we'd have both factors. I'll show you one of those in a minute. So final answer, don't forget the plus minus. It's plus or minus. And I'll just throw it in front of all of them because I don't want to think that it's only the one that's plus and minus. Those are the 6 possible things that work. And you might say, I got to test 6 things? Yes. But do you have to test all 6 things? No. You have to test until you find one. Now, probability would say that if 1 out of those 6 is the answer, then how many things should you have to test before you probably are going to get it? 3 things. Get it? 3. If you've tested 3 out of the 6 things, you have a really good chance you'll have got the one that works, right? Okay, so, and if you're unlucky, yeah, you might have to test all 6 because it could be the last one that you check. Okay, and the other thing is, it is okay with me if you work, not on the test, but on homework, with another person. So it'd be smart, you test these 3, I test these 3. And then, by the time you've done like 1.5 of them, or maybe more realistically 2 of them, you did 2 and your friend did 2, one of you guys is going to find one that works. Know what I mean? So you don't have to test them forever. And besides, you guys are getting pretty quick at doing synthetic, so it doesn't take long to test. So how do I test and see if 1 works? I put a 1 in the box, and I see, does 1 work? And I go, 1, 5, 4 is the numbers here that go in for synthetic, right? So 1 and then a 1, 5, 4, and I do a quick test. And you remember how if they're all positive, you remember that deal? It's probably not going to work, is it? Because it's going to keep growing, 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 unless that last number is really big. And even then, it can't work, can it? Because you'd have to have a negative somewhere to make it work, right? All right, so I can tell you right now that's not going to work, right? Okay, so all of a sudden, I better not test 1 because that's going to waste my time, isn't it? So let's test -1. All right, everybody, test -1 quick. See how long this takes you. Yes?
So basically all numbers are positive.
You got it. I believe so. I can't think of, the only thing I could think of is if there's a 0 in there, that might reset it. And 0 isn't positive, so I guess we can still go back to your statement of if they're all positive. I think you're right. I don't think it'll ever work if they're all positive. All right, so drop it like it's hot. 1 times -1, -1, add them, 4, multiply them, -4. Yay, it worked. And the answer is not that. The answer is, the answer you get, x plus 1, and that's 1x, and that's a 4. There we go. Do I have to put the 1 in front of the x? No. Looks kind of dumb. X plus 1, x plus 4? Yes?
So then what was 2 out of 6 of your solutions like? One of your solutions is -4.
I know what you're saying. We could have checked -1 and we could have checked -4 and both of them would have worked. But there are instances where one of the numbers will come up like, okay, what you're saying is aren't 2 of the 6 always going to work? Not necessarily. Sometimes the one that you have and there's another one that you wouldn't have been able to predict could have worked. Anyway. Okay. I believe that I'm right on that, but it is also possible that I just haven't ever like I haven't done enough of these where I figured out every possible answer. You might be right that there's always 2 that work. I don't think so though. I think there's ones where only one of these will work and then it comes up with some other number for the other factor that you couldn't have predicted. But I'm not positive. All right, so let's get to some problems that you would actually have like on your homework. Here is one of them. X cubed plus 2x squared minus 16x minus 32. That one's kind of brutal because 32 has a lot of factors. All right, FCon, you do not have to write this every time over FCO. You do have to write all the factors out. What are the factors of the constant? 1 and 32. Don't just start with ones that work. And then what else could work with it? 2 and 16. These do not have to be in any particular order, so I just like to make them in like little multiplying problems. 8 and 4. I'm going to go with 4 and 8 because I was going with the smaller number theme there. What's the next? Is there like a 6 times something? I'll make it 32. 7. Nope. Okay, so that's it. And then the factors of the coefficient. Well, that's nice. At least there's only a 1 there. So that's 1. And don't forget a plus and minus. And then everything's just going to get divided by 1. So isn't it pretty much just everything on the top row? Yep. In this case, because we just have to divide them by 1. It's 1, and now I'd list them in order from small to big. 2, 4, 8, 16, 32, and put a plus or minus in front of the whole thing. Those are all the possible things. Now, if you actually had to finish this problem and actually, do it, we'd have to start testing. So let's test by a smart way. We'll divide up the work in the room. So, like this row, I want you guys to use synthetic and test whether or not 1 works. No, wait, you guys do plus and minus 1. We got enough roots that we got to split them up that way. Your row checks plus and minus 1. Your row check plus and minus 2. You guys plus and minus 4. You guys test plus and minus 8. You guys test plus and minus 16. And you guys test plus and minus 32. Okay? All right. See how fast that goes? Somebody found it already. Okay, now just test one of them for me to make sure you know what we're doing here. Just test one of the ones I told you to test. But Mr. K seems to think, actually Mr. T, but anyway, that he's got it. So tell me, you think 4 works? So I'm going to check 4, and then I go. Okay. Explain that to me. He said he tested when he wasn't even supposed to test. So tell me, why did 4 look smart to you? You have good instincts, so why? Okay, and you were thinking, what goes into 16 and 32, 4 does? Ooh, I like it. And there's a lot of negatives in the list of numbers here. 1, 2, negative 16, and negative 32. And so you thought we better have a positive one to multiply by? Okay. Let's double check and make sure he's not losing his mind. Drop this down. 1 times 4 is 4. Add them. Multiply them. Positive 24 and the negative 16 makes negative. Positive what? 4. Yep. And 8 times 4 is 32, and it works. Nice work. Okay, final answer then is x minus 4 for this part right here. X minus 4. And I like to put just a parenthesis, because I'm naturally lazy like a lot of you are. Put a parenthesis around there and just slap in an x for this and an x squared for that. And if there's ever any gaps, I just got to fill them in with a plus. And there we go. So x to the 4th times x squared plus 6x plus 8. What did we really just do? We really just factored this big ugly thing. All right. So that's another way to factor big, ugly, difficult problems. Now, can anybody think of another way we could have factored that one? Divide and conquer had a chance. If I had used divide and conquer here, I would have taken out an x squared, and I would have had x plus 2. And here I would have taken out a negative 16, and I'd had x plus 2. Look at that. Divide and conquer would have worked too. But does divide and conquer work when you have 5 terms? No. Does this work? Yes. Could this work if you had 17 terms? Yes, it could. You can factor something with 972 terms now. You just use this process. Yes, it would. Although, if you had one that had a really, really long, let's say it was like x to the 16th plus 4x to the 15th minus 3x to the 10th plus 72x to the 9th and blah, 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 all the way to the end where you said plus 1. If you had to do f con over f co, what are the factors of the constant? 1 and negative 1. And what's the factors of coefficient? And so that means that you'd have plus and minus 1 divided by 1 is 1. So it's only plus and minus 1 are the only things that could work. The only things you need to test. See what I mean? So even if it was huge, it all depends on that lead coefficient and that end, that constant number. And it might only have a couple things to test. Yes?
Would divide and conquer work if you had 6 pieces?
Divide and conquer can work with 6 pieces, but it's complicated. So if you had 6 pieces, you'd have to get the 6 pieces like this, and you divide them up into like this, and then you have to get this to factor into 2 things, and this part to factor into 2 things, and then one of these would have to match up with one of these, and then that could get brought to the front, and it could work, in theory. Maybe you could. You could actually do two sets of 2, 2, 2. So like I go back here where there was 6 things, and instead of doing it that way, I bet you could do that. I've never even tried that. That and that and that and that and that and that, and get those to have something in common. Maybe. I bet it could be set up, so it could probably work. All right, but this kind I'm teaching you now works for, it doesn't have to be even numbered of terms. It could be odd numbers. So this way we just learned, rational root allows you to factor gigantic things, and it's like the most powerful kind of factoring. All right. Now, nope, that's something from something else. Okay, so are you, if I said f con over f co, do you know how to do that? What's the real name for that? Rational root theorem, RRT. rational root theorem. And notice on the first, your assignment is this packet thingy. You're only doing the first page, the front and back of the first page. On the front of the first page, all it asks is list all the possible roots. Does that mean you have to test them? No. You just list all the things that could be roots. On the second page, you have to actually list all the possible roots and then test them and figure out which one works. Like I showed you, when you divide it up amongst a bunch of people, it works faster. It's fine with me. If you share with a buddy and you're like, you're going to test 2, 4, and 6, and I'm going to test, 1, 3, and 5, or whatever, and you can divide it up, and one of you will find it, but then you have to, if your friend finds it, the 4 works, for instance, you have to do that one on your paper to prove that you found the one that works. Know what I mean? Otherwise, you wouldn't have proof that you actually got your answer, like on paper, instead of just writing it off the key. All right, so your problems are the first page of this packet, and it's coming out right now. Now, how about that homework quiz? The homework quiz is so much easier. It's just simple synthetic. I'm going to hand that out, and I'm going to hand out the worksheet. You're going to finish the quiz in like 5 minutes, and then you can work on your worksheet.